As I recommended to you all on Thursday, I wanted you to go in and read the scope section of each one of these sections of D11. What we're going to work on first today is the general requirements section. Again, that's through the bookmark tab, or if you download it and bring it up in Adobe, you get this little content section where you can come down and select the individual section that we're going to be working in, and that's going to be general requirements. Again, we kind of looked at the table of contents on Tuesday or Thursday of last week, but you also have a list of the tables here and the figures, and they are worth noting what the difference between those are. Tables are going to be essentially, think of embedded Excel sheets. That's going to basically give you a list of parameters, essential variables, things like that. Your figures is just a fancy word for the pictures in this actual code section to be able to provide a little bit more detail. But if we look at the general requirements, we jump right down into it. Again, this is going to be section 1. We see the scope. It says this code contains the requirements, and this is going to be the scope for the whole code. Okay, so this code contains the requirements for fabricating and erecting welded steel structures. When this code is stipulated in the contract documents, conformance with all provisions of this code shall be required, except for those provisions that the engineer, and we'll see what the definition of that is, who the engineer is, or the contract documents specifically modifies or exempts. So there is some stipulations where you can actually work according to this code, but have some modifications to it in a sense. Typically, what you'll see those modifications consist of is basically an addition to the base requirements of the code. You won't see it typically go the other way, where it's actually taking away from the code. It's always going to be, additional requirements. So, for instance, if it said, a 1/16 of an inch of undercut was allowed and so many inches of weld in the fabrication section, an engineer could say, hey, no, I don't want, a 1/16 of an inch of undercut. I want a 32nd of an inch or less of undercut. So that's typically what you'll see as an addition to those requirements stated in this code. We also get, basically a summary of each one of the code clauses, which is just another word for the section. So again, we have general requirements, design of welded connections, pre-qualification, qualification, and that continued list that comes up into the right-hand portion of this page. So looking at the particular limitations, and again, this is going to be the limitations for the whole code, we see that this code was specifically developed for welded steel structures that utilize carbon and low alloy steels that are 1/8 of an inch or thicker. So you're not going to find any sheet metal in here of a 1/16 of an inch, anything like that. It's going to be for 1/8 of an inch and thicker carbon and low alloy steel. So there's not going to be any stainless in it. It's structural steel. We see that it also says with a minimum specified yield strength of 100 KSI or less. Okay, so 100,000 pounds of tensile strength or less is basically the minimum specified yield strength of 100 KSI or less. So you're not going to find anything, any criteria, any recommended fillers, any required fillers for a piece of base material that's got a tensile strength of 120,000 KSI or 120 KSI, 120,000 pounds of tensile strength. It's just not going to be in here. This code is only for 100 KSI or less. Okay, so 100,000 pounds of tensile strength or less. The code may be suitable to govern structural fabrications outside of the scope of intended purpose. However, the engineer, we'll see who that is in a minute, should evaluate such suitability and based upon certain evaluations, incorporate into the contract documents any necessary changes to the code requirements, essentially to make it work for that application, to address the specific requirements of the application that is outside of the scope of code or scope of code. So what it's saying here is, okay, you can use D1.1 for something other than, structural steel, but that's going to have to be specified by the engineer, or it's also going to have to be incorporated in the contract documents what changes need to be made to make this code actually apply to the work that you're doing that's outside of the structural steel kind of envelope. So it says the Structural Steel Welding Committee encourages the engineer to consider the applicability of other AWS D1 codes for application involving aluminum, D1-2, sheet steel or equal to or less than 3/16 of an inch thick, D1-3, reinforcing steel, okay, concrete, stuff like that, reinforcing steel, D1-4, and stainless steel, D1-6. So what you're going to see is these D1-2, D1-3, D1-4, D1-6, and D1-5, the bridge welding code, are going to have a common theme that are going to be kind of running through them. They're going to be of similar size, similar, all the AWS formatting is going to be somewhat the same, but you're going to find that these are going to complement each other in the sense of structural. It's just we're going to have one that pertains to structural steel, which is this code, structural aluminum, which is in another code, structural sheet steel, things like that. It's going to be highlighted in those other codes. So really that limitation is just based on, hey, this is for structural steel of this size and with a minimum yield strength of 100 KSI or less. Okay, so no 120,000 K or 120 KSI steels, things like that. We look at the definitions here. It jumps straight into the definition of engineer. We see in 1.3.1, engineer shall be defined as a duly designated individual who acts for and in behalf of the owner on all matters within the scope of the code. So it doesn't necessarily say that the engineer has to be an accredited engineer through the engineering or the accredited engineering board. It doesn't say that they have to be a PE or a professional engineer through that accredited engineer board. It just says that they have to be defined as a duly designated individual who acts for and in behalf of owners on all matters within the scope of the code. So technically, they could take somebody with 20 years of experience that has, the required experience of, fabricating these structures, working in accordance with this code, put them down as the engineer of record. Is a common term you'll hear, and that will satisfy the requirements of this engineer. So typically you will see that engineer of record is holding or withholding of a engineering degree or an engineering credential, whether that be through the American Welding Society or ABET, the American Board of Engineering and Testing, I believe. Got to remember that one. So looking down at a few more, we see that this is definitions 1.3. We break into all of these, continued definition. We get things like the contractor. When they're referring to a contractor, contractor shall be defined as any company or individual representing a company responsible for the fabrication, erection, manufacturing, or welding in conformance with the provisions of this code. Okay, so they're setting aside who these people are. Inspectors, whether that's a contract inspector, a verification inspector, or an inspectors which could be considered unmodified. Let's look at those briefly and just look and see what they are. Contractor's inspector shall be defined as a duly designated person who acts for or in behalf of the contractor on all inspection and quality matters within the scope of this code or the contract documents. Okay, verification inspector. Verification inspector shall be defined as the duly designated person who acts for and in behalf of the owner or engineer on all inspection and quality matters specified by the engineer. So, for instance, when I'm working with Duke Power, I'm typically working for a contractor of Duke Power. That would classify me as the contractor's inspector for welding. And I will constantly communicate, tie out, send my inspection reports to, and be in close contact with the verification inspector, which is maybe like the Duke Power quality inspector, something like that. And then we get into this kind of more vague terminology of inspectors. When the term inspector is used without further qualification as the specific inspector category described above, if it's not one of these two, it's saying it applies equally to the contractor's inspector and the verification inspector within the limits of the responsibilities described in 6.1.2. So that's actually the fabrication sections where it's sending us there. And basically what it's saying, if it doesn't sit there and say it's the contractor inspector's responsibility, and it doesn't say it's the verification inspector's responsibility, then it's going to use this terminology, which is going to apply that it's both of their responsibility, or that's one instance. OEM, original equipment manufacturer. OEM shall be defined as a single contractor that assumes some or all responsibility assigned to this code to the engineer, assigned by this code to the engineer. So it's the original equipment manufacturer. We don't need to really go through all of these definitions, but one thing I want you to look at is this code terms shall, should, may. Shall, should, and may have the following significance. Shall, code provisions that use shall are mandatory unless specifically modified in contract documents by the engineer. Should, the word should is used to basically promote recommended practices that are considered beneficial but are not requirements. May, the word may in a provision allows the use of optional procedures or practices that can be used as an alternative or supplement to the code requirements. Those optional procedures that require the engineer's approval shall either be specified in the contract documents or require the engineer's approval. The contractor may use an option without the engineer's approval when the code does not specify that the engineer's approval shall be required. So what it's saying here is if it lays out in the qualification section that on this particular type of material, the contractor may use a pre-qualified WPS or a standard WPS, then what they're saying is that, hey, there's an option here for the contractor to utilize this pre-qualified rather than, for instance, as we covered on Thursday, actually building that whole qualification system. So there's just a few of the definitions. You see that the responsibilities kind of pick up at the bottom of that page and work onto the right-hand side here. So when we look at the responsibilities, first thing we jump into the engineer's responsibility. And it's good to kind of note these engineers' responsibilities, because that does draw a clear line in the sand of what the responsibility of the inspector is from the actual, engineer or the contractor. But I just want to, put emphasis on this is where the engineer's responsibilities are, but we're not going to dive into those too extensively. We're going to look at the contractor's responsibilities and the inspector's responsibilities. So we look at the contractor shall be responsible for WPSs, qualification of the welding personnel, the contractor's inspection, and performing work in conformance with the requirements of this code and contract documents. So what it's saying is the contractor that is doing work, if my company, Matt Broom LLC, is building a structure for Duke Power, I would be considered the contractor. Duke Power would be considered the owner. In that case, I would be responsible for verifying that the WPSs, or the welding procedure specifications, would work according to what the owner wants built. I have to make sure that my welding personnel have been qualified and that the contractor's inspection and performing the work, that basically we're conforming, all of our work is conforming to the requirements of this code. The inspector responsibilities. So either the inspector that Matt Broom LLC hires, contractor inspection, or Duke's inspector. Let's see what their responsibilities are. So contractor inspection shall be supplied by the contractor, so I would have to supply that person, and shall be performed as necessary to ensure that the materials and the workmanship meet the requirements of the contract documents. We see that the actual owner, again, the owner's inspector, or in this case, they call the verification inspector, the engineer shall determine if the verification inspector shall, or if verification inspection shall be performed. Responsibilities for verification inspection shall be established between the engineer and the verification inspector. So basically what it's saying there is, the engineer can take that role or that responsibility if they're qualified, or they can put somebody in that position to basically be that middleman between the contractor inspector and the verification inspector. Okay. So that's looking at the responsibilities. Now we look into the approval. You see that it's a very short little clause here. All references to the need for approval shall be interpreted to mean approval by the authority having jurisdiction or the engineer. So that's who's going to be the approving authority to say whether something is good or bad, or if there is any instance that the code says that approval is needed before this next step. That's what it's talking about in the use of the language of approval. We see that welding symbols shall be shown in the latest edition of AWS 2.4, which is the symbols for welding, brazing, and non-destructive examination. Special conditions shall be fully explained by added notes or details. So what it's saying there is the symbols that we're using, just like the Hobart Symbols for Welding workbook that all of you used through your symbols and specifications course, where those symbols are pulled out of directly is A2.4, okay? So that's kind of the standard for those welding symbols. Where do we get those from? So safety and precautions, here's a big thing a lot of people don't understand. Safety and health issues and concerns are beyond the scope of this standard. So what it's saying is this code has nothing to do with the safety and health of welders. It's not going to tell you if a certain material is hazardous to breathe in. It's not going to tell you if a certain process or cutting operation is hazardous to the body, anything like that, and therefore are not fully addressed in this code. So they're not addressing any safety or health concerns in this code. It is the responsibility of the user to establish appropriate safety and health practices. Safety and health information is available from other sources, including but not limited to ANSI Z49.1, which we've talked about. It's the safety in welding, cutting, and allied processes, or the manufacturer safety literature on the equipment and materials that you're using. Okay, so that's where we're getting the safety side of it. That's why you'll typically see, and especially more of a structured contract environment, you'll have basically, job supervision or contract supervision, which is, the work supervision side. You'll have obviously the work, the welders, the fitters, things like that. You'll have then quality, which is basically at that job site supervision. They're very closely related because they're essentially working to the same goal, except the job supervision is typically going to be required not only to assess whether the product that they're making is quality, but it's also going to be that it's done according to time schedules, that the proper materials have been sourced, things like that. The quality is going to make sure that those materials do conform to the quality standard, as well as any fabrication or actually the making of the product has been done correctly. Safety is typically that third person that is going to be focused really around all the, the letter organizations, whether it be OSHA, MSHA, whatever is applicable there, ANSI, and making sure people are working safe and they have the proper PPE to be able to perform this work. Okay, so and again, what it's saying there is, where it's limited but not limited to the following. We picked up manufacturer safety literature on equipment, also the applicable federal, state, and local regulations. That's where OSHA comes into play. Annex R, safe practices. And then the work done in conformance with this code may involve materials that are classified as hazardous. The user should determine the applicability of any regulatory limitations prior to use. So that's what they use in the safety terminology. They call it safe working exposure, exposure limitations. There's a key term there, but basically how long you can be exposed to the material. What it's saying is this is almost like a liability clause, okay? What they're saying is, well, we're not telling you how to do it safe. We're not telling you what could be bad for you, what could, be dangerous, anything like that. We're just telling you how to make this and make it correctly. Okay, so that's just a liability clause that the lawyers put in to basically shield them from, telling, when they tell somebody how to manufacture this or make this, structural steel connection, that they don't sue them because that led to their, negative safety impact or, some type of hazard has come from that. All right, so it's a lawyer clause. Standard units of measure. Basically, this standard makes use of both U.S. customary units, which is imperial, and the international system of units, which is SI or metric. So you'll see both fractional and metric dimensions on here. The measurements may not be exact equivalents. Therefore, each system shall be used independently of the other without combining in any way. The standard with the designation D1.1 2010 uses U.S. customary units. The standard D1.1M, M is for metric, uses SI units. The latter are shown within brackets. So if a company comes to you and said they're working according to D1.1 structural steel, and they say that all of our materials are in SI or metric, technically what they're telling you here is it's not sufficient to have just one copy of the code, D1.1 2010. You would actually have to have D1.1M metric, because they are not necessarily exact equivalents, which means that you can't just do a conversion. You'll have to actually use the code to see what it specifies. I've seen people get caught up here a little bit, that whenever they're working to metric documents, and let's say the code requires a 1/2-inch fillet weld, they sit there and do a conversion. That's 12.7 millimeters. Typically, the code's going to be cross equivalent, but I've found that in some of the M versions or D11M, where it is all in metric dimension, it would just round that up to 13 millimeters, which then 12.7 would not be sufficient. Okay. Reference document Annex U lists all documents referenced in this code. So that's at the back. All the annexes, just go ahead and assume, are going to be at the rear or at the back of this code book. And that's all our general requirements. So basically, with an understanding of this, you can know, one, the application of this code, who this code is for, some of the key definitions of when they say a term, who they mean, and really just what we are able to use this code for. So that's really where the general requirements help us and determine how we can best apply this code and whether it's applicable in the first place. So hope that was helpful for you guys. Again, that's a real short, pinpointed lecture on the general requirements. If you do have any questions in regards to this, please feel free to shoot me an email or give me a phone call. Again, this week I'm going to be tied up in training for the majority of the week, but I'd be glad to answer any emails, in regards to this section. And tune back in. This will basically satisfy the Tuesday lecture. That's Tuesday, January the 26th. Tune back in on Thursday, or if you see that next link below showing the next video, we're going to begin jumping into the pre-qualification section. Thank you guys. Hope you have a good day, and we will see you next time.